So the next case, use trapezoidal rule with 6 intervals to determine the value of the integral from 1 to 1.6 of ln of x dx. Correct to 3 decimal places. So the first step, as usual, you fix the calculator to 3 decimal places, isn't it? Then, in trapezoidal rule, what do you know? In trapezoidal rule, the number of strips is the number of, the same as the number of ordinates minus 1, isn't it? So it means when we have 6 intervals, because each strip has its own interval, isn't it? So 6 intervals means we have 6 strips, or 6 parts, isn't it? So 6 strips, 6 intervals means 6 strips, isn't it? So if strips are 6 in trapezoidal rule, how many ordinates are those? 7 ordinates, isn't it? And the trapezoidal rule start at this point, exactly this point, isn't it? Are we together? So what is important in trapezoidal rule? To get edge. So can we get edge? We are starting from 1 and we are ending up to 1.6. What is the whole of this range? 1.6 minus 1, the whole range is 0.6. So what is edge? You want to divide this length of 0.6 into how many equal intervals? In 6 equal intervals, isn't it? You have a length of 0.6 which must be shared in 6 equal intervals. Are we together? So a length of 0.6 must be divided into 6 equal parts. What do you get to be the height of each and every strip or part? 0 point? So I've got an edge. And you know in trapezoidal rule start exactly at this first interval 1, isn't it? So 1 plus edge gives you the next one until you reach the end 1.6. Are we together? So from there, we now construct the table. The reason why I'm saying it is good to construct the table before writing the formula so that you will see which ordinate gives you the last interval there, the last ordinate for x there, isn't it? Are we together? So you start from 1, construct your table. Your table has now, the first one, it starts from x. Have you placed the number of decimal places? 3. So you divide your table. If I talk of 6 intervals, meaning the minimum number of 6 intervals, in trapezoidal rule I'm talking about 7 ordinates, isn't it? Serious? In trapezoidal rule 6 intervals, 7 ordinates. So 7 parts, 1, 2, 3, 4, 5, 6. Are we together there? Yes. In the number of strips in trapezoidal rule is the number of ordinates minus 1. So 6 intervals, each interval is for each strip. That means 7 ordinates. So the first ordinate is x naught. It starts at exactly where it is starting. Mid ordinate is what starts in the middle. Does not start at that point, isn't it? Are we together? So the first ordinate x naught start at 1, isn't it? Are we together? Then now, what is x1? You put edge. Your interval is 0.1, isn't it? Meaning what is important is always to get this x naught. Is what is important. The rest is just plus edge. Isn't it? Are we together? So x naught plus edge, what do you get to be x1? Yes. Then x2, 1.1 plus edge. Then x3, 1.2 plus edge. Then x4, 1.3 plus edge, 1.4. Then x5, 1.4 plus edge, 1.5. Then x6, 1.5 plus edge, 1.6. So you see the last ordinate will give you the last interval there. The last ordinate for x there in the interval of the integral, isn't it? Are we together? So we've reached 1.6, meaning x6 is the last ordinate. So the number of ordinates is the number of strips plus 1. 7 ordinates. So start. For you to get area, you are supposed to integrate f of x dx. So if y is a function of x, where there is f of x, you put y, meaning you are integrating y dx, meaning the whole of this ln of x is y, so that you have y dx. So what is y according to this integral ln of x dx? Y is ln of x, so that one should be on top here. Y is ln of x. So you start. When When you have x naught, you are getting y naught. Are we together? You are getting y naught. So if this is y naught, that is x naught. So y naught is ln of x naught, ln of 1. What do you get to be y naught? 0. I have moved to y1 with x1. y1 will be ln of x1. When you put 1 in y, you put 1 in x. So y1 is ln of x1, isn't it? So ln of 1.1, 0.095. And y2, if you put 2 here, you put 2 there. So y2 is ln of x2. So ln of 1.2, 0.18. And y3, 0.2, 62. And y4 is ln of x4, ln of 1.4, 0.336, isn't it? And y5, 0.40. Then y6, ln of x6, ln of 1.6, 0.47, 0, isn't it? 0.470. Good. So from there you list your ordinates. We have y0, y1, y2, y3, y4, y5. The last one is y6. So what is area according to this trapezoidal rule? Area's trapezoidal rule, it is a half h, isn't it? Are we together? A half h into, you add the ends. The ends is y0 and y. Are we together? y0 plus y6. Then plus twice what is left, isn't it? Are we together? So what is left? See, these ones are the ones which are left. y1 plus that y5. So you have dealt with everything. So what do you get? A half times the value of h. H is 0. Then in bracket start y0 plus y6. 0 plus 0.470. See, 0.470. Then plus 2 into bracket, you add this. Get me what is here. 2, then open bracket y1 plus y2 plus y3 plus y4 plus y5. What do you get with the whole of this second part? 2.560. You are in agreement there? 2.560. So in the end, you've already worked this smaller bracket, so you can now deal with that. So what is half times 0.5 in bracket? You add that. What do you have? 0.15. 2. So in trapezoidal rule, we are also getting 0.152 because it was in 3 decimal places. If it was more than 3 decimal places, they were approximately not going to be all the same, isn't it? One might have been 0.1522, the other one might have been 0.1519. Are you seeing such kind of cases, isn't it? But in 3 decimal places, the 3 rules gave us the same answer. Trapezoidal with ordinate and the Simpson's rule. Are we together? So the idea is you must always know how to get the x naught. Then the rest, you simply add h, isn't it? Getting x naught for trapezoidal and Simpson is the first interval here, but we don't need rule. You have, it is not this one, it is starting at the middle ordinate in that given interval, isn't it? Are we together? Good. So that is how to handle that case.